This is a question from section 8.1. But before we move forward, you want to make sure you know what a critical value is. When it pertains to hypothesis tests, there are three types of tests, and depending on the type of test that you do, the critical value is either going to be in the left tail, the right tail, or the left and right tail of the normal distribution. And I'm focusing on the normal distribution here because this particular question is asking us to test a claim about a population proportion where that population proportion P is less than 0.71. So anytime you're testing a claim about a population proportion, you're always going to use the normal distribution, which means your critical values are going to be z-scores. So again, critical values are z-scores. There are three situations. If you have a hypothesis test where it's going to be a left tail test, then your critical value is going to be a negative z-score with an area of alpha to the left. So in this particular problem, we're using a significance level. So that's your alpha. Alpha is called the significance level of 10%. So this means that the area to the left of that critical value of that z-score has an area of 10% or 0.10. So this is the critical value for a left tail test. Remember at the center, the z-score is 0. If we have a right tail test, then your critical value is going to be in the right tail. And again, it's a z-score, so it's going to be a positive z-score, we call z sub alpha, where the area in the right tail will have the value of your significance level. So here again, using a significance level of 10%, the area of the red shaded region in the right would have an area of 0.10. The third type of hypothesis test is a two-tail test. Two-tail tests always occur when your alternative hypothesis contains the not equal sign. And so in a two-tail test, you take your alpha and you split it equally in both tails. So the region in the left tail is half of alpha and the region in the right tail is half of alpha. So half of 10% is 5%, so that would be 0.05 in each tail. So the critical values, you're going to have a negative z sub alpha divided by 2 and a positive z sub alpha divided by 2. So you can find these critical values by using the z-table. I will show you how to use the z-table and then also how to use this on the calculator. So let's now take a look at this problem, and then we need to talk about what a test statistic is. So in hypothesis testing, when you test a claim, in this particular problem, the first thing that we're going to do is write our null hypothesis and our alternative hypothesis. The null hypothesis always contains the null hypothesis value, which we assume is true. So the null hypothesis here is we assume that the proportion is equal to 0.71, and then we're going to test the claim that the proportion is actually less than 0.71. So because the alternative hypothesis contains the less than sign, this is going to be a left tail test, which means that we are looking at the normal distribution where the area shaded in red here is our significance level, that's alpha. And so the z-score that separates that region of 10% on the left, that's our critical value. So this is going to be z sub alpha, which is z sub 0.10. So again, this is called your critical value. And again, a critical value is a z-score, okay? So at the center of the normal distribution is 0. So we know our z-score here is going to be a negative value. So using the table, because 10% is the area to the left, we're going to look for where in the body of the table can we find a probability that is closest to 0.10. So if you look at the first column here, go down to the row negative 1.2 and then go to the column 0.08, you'll see that corresponds with an area of 0.1003. I know it's kind of hard to see, but that tells us that the critical value, or the z-score that separates, so I'll just write it below here, that red shaded region on the left is a critical value of negative 1.28. So that's your critical value. Now, when we do a hypothesis test, typically what we do to test a claim is we, do a study or collect some data, and then from that data, we calculate some sample statistics. Because we're testing a claim about a proportion, the sample statistics of interest here is going to be some sample proportion or some p hat. In this particular problem, we're not actually told what p hat is equal to, but that's fine. What we are told is that the test statistic that corresponds to this sample proportion, p hat, whatever that number is in this particular problem, again, it's not relevant here, but this is our sample proportion. right? What you do is you calculate a corresponding test statistic. So that test statistic, we call that a z-score, right? And we call it a test statistic is because we test it to see if it's significant or not, or more specifically, statistically significant. So in this particular problem for this specific p hat, its test statistic is a z-score of negative 2.91. So what this negative 2.91 means, I'll highlight it in green, is right? It means that the sample proportion that we got in our study shows that if the null hypothesis is true, so assuming that the population proportion is 0.71, right? Does our sample data show that there is enough of a difference between what we actually found in our sample data and the assumed null hypothesis value of 0.71? So because our sample proportion has a corresponding z-score of negative 2.91, when I plot that on the normal distribution, that's going to be to the left of negative 1.28. So negative 2.91, which is our test statistic, we see that it is significant, statistically significant, because that value is really far away from the center, which is where we find our null hypothesis value. This indicates that there is a significant difference in the proportion, and that in fact the proportion is actually less than that null hypothesis value of 0.71. And so if you're using the critical value method, you can see here that the test statistic of negative 2.91 falls in the critical region. The critical region is the region that is shaded in red. It is your significance level. So because the critical value falls in the critical region, or I wrote value here, but I meant critical region, right? Well, then what we would do in question B is we would reject the null hypothesis. So rejecting the null hypothesis means that we reject the claim that the proportion is equivalent to 0.71, and we have enough evidence to support the claim that the proportion is actually less than 0.71. The other method for making a conclusion is to use p-values, and you'll learn about that later on, okay? But this is the critical value method for rejecting the null hypothesis. If you want to use the graphing calculator instead of the z-tables to find critical values, then when you are on the normal distribution, so this is for normal distributions, meaning we're looking for critical values that are z-scores, you would use inverse norm. So to get to inverse norm, go to your calculator, you're going to press the second button, and the vars button is going to get you to the distributions, and then you're going to go down and choose inverse norm. So inverse norm is going to ask you to put in the area that's to the left of the critical value that you want to find. So here that's 0.10, so you type in the area to the left, and we're on the standard normal distribution, so mu would be 0 and sigma is going to be 1. And when you press enter, the calculator will give you a z-score of negative 1.28. So negative 1.28 is the critical value for a significance level of 0.10 for a left tail test.